For this problem, we have two different samples, drivers from the south, and the proportion who wear seatbelts, and then drivers from the northeast, the proportion who wear seatbelts. So our claim is that the proportion of drivers who wear seatbelts is greater in the south. So that's for this first part. It's south's going to be greater than the northeast. So that's going to be our claim that our proportion for population number 1 is greater than population number 2. So that needs to be our alternative hypothesis, that population 1 is greater than population 2 proportion-wise, which means the alternative, or the null, is the less than or equal to. The null always has the equal value in it, and it's the opposite of the alternative. So that's for our setup for our hypothesis test. The critical values now are going to be based off of our level of alpha. I'm going to jump over to Excel. Here in Excel, my sample 1, drivers from the south, I have the number that there were. The sample proportion is how many wore the seatbelt out of the total number. And now for the northeast people, the number in that sample, how many wore their seatbelt out of that total number is the sample proportion. So our alpha here was set at 0.09, and our rejection region, we're using the normal distribution, so equals norm.s.I and v, and just put 0.09 in there. And Excel always gives you the left-hand tail critical value. Now our alternative was a greater than, that the south is greater than the north proportion-wise. So this should actually be a positive 1.34 for your answer. Is the same numbers, but Excel always just gives the left-hand critical value. And so the rest of this actually just calculates the test statistic for you. This spreadsheet does, using these formulas that are listed in the book. So this first part here is doing the estimate for the population proportion, which is right here, adding the two X values together, how many wore a seatbelt in each sample, add those together, and divide by the total number added together that were in each sample. So kind of getting that pooling both the samples together basically into one big group is P bar, our estimate for the population proportion. And then you just do 1 minus that to get our Q bar. Okay. And then down here, our standard deviation for the test statistic, just doing this bottom part right here. So those two values we just calculated, multiply those together, and then multiply it by 1 over the size of the first sample plus 1 over the size of the second sample. Do all that multiplication and take the square root of it. So the formula is already in this spreadsheet here. With the square root of those two things multiplied together, the P and the Q, and multiplied by 1 over the size of the first group plus 1 over the size of our second sample group. And from that then, to get our standardized test statistic here, that's the bottom part of the formula. And the top part, it looks more complicated than it is because we're assuming the two proportions would be equal. So this would reduce to 0 here. But that first part, the sample proportions, subtract them from P1 minus P2. So those two sample proportions get subtracted, and we divide by that standard deviation. And we get our standardized test statistic. And so using the critical value method, just compare that to our rejection region, positive 1.34. This is larger than positive 1.34. So it's further into the tail. It's in the rejection region. So we reject our null hypothesis, which means we're accepting the alternative, which was our claim, that the drivers in the south have a larger proportion of them wear seatbelts than in the northeast. So we have enough evidence to support our claim because we are rejecting the null and accepting the alternative hypothesis.